Hello everyone, my name is Wenjun Tao, a senior software engineer at JD Company. I'm also the core member of our Presto team. It is my honor to share our works on Presto and Alluxio. Now let us dive into today's topic, the practice of Presto and Alluxio in e-commerce big data platform. I will show you from the four aspects. First of all, an introduction of JD Company's BDP architecture. Secondly, practice with Presto in BDP. Third, Presto and Alluxio stack. Last but not least, our going on exploration. First of all, I will give a brief introduction to BDP of Jingdong. Jingdong is one of the largest e-commerce companies. There are tens of thousands of nodes and tens of PB offline data, which requires millions of Spark and MapReduce jobs to process every day. And there are hundreds of PB dates and tens of PB data increase. There are tens of business units, hundreds of data models. This is our BDP architecture. We deploy HDFS as our underlayer distributed file system. Hive, Presto, and Spark serves as our computing stack. Yarn serves as resource manager and job scheduler. Alluxio works as a bridge between HDFS and the computing frameworks. Well, let me show you practice with Presto in our production environment. As its main tool, Presto cluster consists of coordinates and multiple workers. Coordinates is responsible for resolving queries from clients, analysis plan queries, and interactive with high methods. And the workers are responsible for read data from data sources such as HDFS and process data, and then return the results to coordinates. Then coordinator return the results to the client. In order to adopt Presto into our production environment, we make some modifications. Since we use Yarn as unified resource manager, we deploy a customized Presto on Yarn cluster in our production environment, which is easy to maintaining and scaling. Users have high demands on business and isolation, so we implemented the job isolating schedule and to make the cluster more stable. In addition, we combine an ERP authorization system with Presto. In order to allow dynamic management, a power server was developed with this system. With this system, we can modify configurations of cluster at runtime, and will give a detailed I'll give a detailed exploration of this system later. According to the query feature, we also developed the query results catch function. This is our Presto on Yarn architecture. With this unified resource management, we can dynamically scale the number of workers. And we benefit much from it. First, it implements a set of physical resources to run several types of applications. We don't need to deploy Presto and Presto cluster specifically. Just submit a Yarn job. Secondly, we can use Yarn mode to flexibility scale the size of Presto clusters while managing resources in a unified manner. Third, we don't need to consider the resource competition between node manager and Presto load. here is our customer's powerful system. It can manage plugin for Presto classes that can be used to export query results, collect to different data stores, and more. And the ERP authorization is used to check the legality of query tasks and facilitate auditing of user query tasks. With the dynamic configuration feature, we can dynamically adjust to the routing ruler and resource grouper of query jobs to offload jobs to different clusters. In addition, to start or stop a Presto cluster, Power Server can also expand or shrink the cluster. This is our Presto schedule with smart job isolation practice. We use a Presto resource group feature to limit the CPU and the memory usage of different users. Resource group, yeah. For some test jobs and some resources intensive jobs, we provide a specific resource group for these tasks. And the jobs assigned to this group will run on a set of independent nodes to avoid some jobs affecting the performance of the entire cluster. This is our job isolation feature for resource group. Because learning managers run different types of service at the same time, they may cause works to fail to perform query tasks. To do this, the worker particularly reports the status of loads to master, and the master will temporarily exclude these workers' loads to ensure stability of query tasks. Our Presto class is mainly for predictable queries. These queries are used to generate everyday reports. Their features are controllable data range, high query frequency, high data reuse rates, high proportion. Occasionally, users with Presto to make customer queries. These features are just optimized. According to the query feature, we developed the query result catch function. The advantages are regular calculations for workers, return the query results quickly, relieve cluster pressure. First step, we develop a cache function based on TTL. Owing to so many users, there will be many identical circles in the same time periods. However, if table updates by users, the cache results may be dirty. So we develop a cache function based on the high mass store. According to the last modification of time of mass dates, we can judge whether the date has been updated so as to determine whether the cache is invalid. However, there's still some room for improvements in cache hit rates. So we develop a query pre-execute, such as predictably execute the frequency queries. This graph shows the query status of last 6 months. There are about 1 million queries every day, and each query costs about 5 seconds. Let's begin with the important part of our presentation today. To speed up our queries and make our service more stable, we have deployed Alluxio in our Presto production environment 2 years ago. Then I will talk about our experience. Alluxio is a virtual distributed file system that unifies data access between storage and computing, and offers memory speed performance while accessing remote when working on remote states. We have deployed Alluxio in production and test environments, including Presto on Alluxio and job history on Alluxio to access user query and logging analysis. Take advantage of Alluxio's caching feature. We can achieve high query throughputs. Different number of jobs are running at different times, so our HDFS class have inconsistent response time. After we deployed Alluxio, we get a consistent low query latency. Furthermore, benefits from caching policy, we also eliminate network traffic. That's we think it is best to run Presto and Alluxio together. First, let me introduce our improvements to Alluxio. These are some features contributed by Jingdong, such as adding new web UI features, improving shell commands, checking file cache consistency, what's the evict strategy, and JVM pulse monitor. There are also some bug fixes and tests. Next, I'll give a brief introduction to what might evict strategy and cache consistency. There are two models of eviction in Alluxio, synchronized and asynchronized. For synchronized model, each time users request to load a file, it checks whether the storage is sufficient. If it is not sufficient enough, it will release space according to LRU algorithm. When the workloads are write-heavy, it is recommended to use the synchronized eviction. Asynchronous eviction relies on a predictable space reserve threads in each worker to evict the dates. It waits until the work storage alternative reach a configurable high watermark. Then it evicts the data based on evict policy until it reaches the configurable low watermark. To ensure the dirty data is not reached, we must maintain data consistency between Alluxio and HDFS. There are 3 ways to check file consistency, such as users call RPC API, such as get fields, get file info, list status. Third, second is a RESTful API. By RESTful, such as reload metadata to trigger Alluxio to reload all metadata. Third, when Alluxio starts up, it will check metadata consistency. Alluxio will traverse all files in directory to determine whether the file exists, and the file size and the file modification time are consistent with the under file system. The Presto on Alluxio has led to more than 10 times performance improvements on average. Alluxio has been running in our production environment on more than hundreds of loads for 2 years. After we use Alluxio and Presto together, we have got many benefits, such as high performance, consistent low query latency, eliminate network traffic. There are also other benefits. What's more, Alluxio is a fault-tolerant, pluggable, and optimization component, so we don't need to shut down cluster to upgrade whole cluster. And we can reduce the network consumption by using Alluxio external caching capabilities to provide better support for ad hoc and real-time stream computing. Please see the left of this page first. Before using Alluxio, Presto Worker may read the data from remote data nodes in large probability. It costs many time for network latency, and then see the right parts. After using Alluxio, Presto Workers can read the cache data from Alluxio. On the same load, it can reduce remote rates from HDFS and isolate high-load state nodes with cache, which can improve access performance. Therefore, Alluxio can bring locality and isolation. As we can see in this picture, for the first time, Presto wants to read data from Alluxio, but Alluxio can't find data in memory. So Alluxio read data from HDFS instead of. But after the first reading, Presto gets the data from the memory of Alluxio instead of from the disk of HDFS. We changed the Presto logic read split so it can access HDFS automatically when Alluxio service is not available. Our work also extends Alluxio and enhance the synchronize between Alluxio and the HDFS consistency. This is a Presto client command line. We execute the same circle query for many times into Presto cluster. The left one, Presto access HDFS directory. The right one, Presto use Alluxio as a memory cache. Read rectangle is a circle cost time. The left one shows the cost about 10 seconds every time. And but the right one, which after using Alluxio, it spends 20 seconds for the first time. 26 for the first time, but less than seconds in the following. The left is slower than the right, obviously, because we use Alluxio to cache the table and the partition files. So after first time, Alluxio can accelerate the queries. This is another view. It is Presto Web UI. We can get the same results with the command line. We can see the query cost from the 10 seconds to less than one second. It is very exciting. This line chart is described as the summary of these tests. We can see the Presto Alluxio can reduce the read time after first read and run much faster than the Presto cluster. Currently, we are exploring how to use Presto and Alluxio to get the better performance. Okay, I'll introduce some other challenges we are going on. Presto master loading balance here. As the amount of data grows, the cluster size becomes larger, and the number of queries starts to increase, must become the performance bottleneck. To achieve load balancing, how to improve Presto will be a challenge. Thread-level resource isolation to the execution task running on the workers compete for resources, especially the jobs in the test thread. If we can restrict the execution task with C groups, it will reduce the mutual impact among queries. Unified large cluster. Large-scale clusters help improve resource utilization. In past year, we have reduced the number of clusters from more than 100 to 20. Within ensure query efficient, we will further increase the class size and reduce the number of clusters. This is Alluxio exploration. Explore more application scenarios. Store, MapReduce, or Spark Shuffle to reduce disk storage pressure and speed up access to the shuffle. Third, porting HDFS authentication to Alluxio. We are going to port custom authentication on our HDFS to Alluxio. Third, HDFS, RBF, or Alluxio. We have tried to use HDFS root-based federation, but the performance didn't meet our online requirements. We found that Alluxio also has the forwarding compatibilities and hope that Alluxio will perform better. That's what we are doing. That's all. Thank you for your time.
Great. Thank you so much. Appreciate taking time. Any specific questions you want to look at the chat since you're online?
Okay.
We have about 4 minutes before the next speaker comes in.
Okay, I can explain what Eric asked us. His question is, Alluxio caching the HDFS data in Alluxio, or is it is caching the SQL result in Alluxio? In our production environments, Alluxio was used as formal caching the HDFS dates, and we cache the SQL results in the RocksDB in the master node locally, just at the master node disk. Or we can cache the SQL results in HBase, so that multiple clusters can share the query results. Okay.